And lesson 18 is called more problems on area and circumference. So today in lesson 18, and I'm going to write that at the top. So we've got lesson 18 here. We're going to take a look at lots of different shapes and maybe even some shapes combined together. So let's say we have a rectangle and a square and they're combined together and they're supposed to show you a room. We're going to use the information that we know about finding the area of each of those shapes to find the area of the entire room or the entire shape. So we're going to be looking at that today. And we're going to start by looking at finding the area of a semicircle and the area of a quarter circle. So it's important for us to remember the equations that we're using as we're doing these problems. So I want to remind you that the area of a half circle or the area of a semicircle, I'll write semi here for semicircle. So remember, a semicircle is like the first problem that we're seeing right here. So the area for a semicircle, and you should absolutely write this down, is area equals 1/2 pi r squared. And we talked about this very briefly last week, I think on Friday. And so this is kind of a review for you guys, just to make sure that you fully understand what we're talking about. So that is how we find, that's the equation we use to find the the area of a semicircle. Remember that r equals radius. And remember that radius, so if we have a circle here, and my circle is going to be very bad. So remember, if we have a circle, our distance all the way across the circle is called the diameter. And the distance halfway across the circle is called the radius. So when they ask us for the radius, they're asking for that distance halfway across the circle. So from one edge of the circle to the center of the circle is the radius. So that's what we need to know when we are carrying out the area, or when we're trying to find the area of a circle, a semicircle, or a quarter circle. So the next problem here is going to ask us, what's the area of this quarter circle? And we've not actually looked at the equation for the area of a quarter circle. So I'm going to write that out for you guys. And I want you to remember something. I want you to remember that the area of a circle is pi r squared. And so in us finding the area of a semicircle, since a semicircle is half of a circle, we just need to multiply that original area by 1/2 because we're finding half of the area of that circle. When we're looking at a quarter of a circle, since a quarter is 1/4 of the bigger picture, we're finding 1/4 of this circle. So that means that we're going to write our equation as 1/4 pi r squared. We just need to multiply the area of the entire circle by 1/4 since we're only looking at 1/4 of that circle. So we're going to dive right in and take a look at each of these problems. And I want to remind you guys that in the last lesson that we looked at, and in this lesson as well, there are 3 different ways that we can look at pi. So I'm going to write them out really quickly, and then we're going to pay attention to what the problem is asking of us. So remember that pi is a non-terminating, non-repeating decimal. So that means that it is a decimal that does not end, and it is a decimal that does not repeat itself. So that means that instead of us saying, well, it is 3.1516, 1516, 1516, it is not a repeating decimal. So it is 3.1415, and each number is different for the succession of the decimal. It doesn't end, and those numbers do not repeat themselves. So you might see the numbers again, but there will not be a pattern in terms of those numbers. So I want you to keep in mind that throughout this workbook, we are representing pi in 3 different ways. We're representing it as we round it to a decimal of 3.14. We're also representing it as 22/7, which is an odd and not very good approximation of pi. And then we're also representing it as pi, in which you would type into your calculator the symbol pi, and that would give us that non-terminating, non-repeating decimal. And so our answer, if we were to use the pi button on our calculators, would be much closer to the real answer than if we were to approximate pi with 3.14 or 22 over 7. So we're going to be keeping that in mind today as we're going through these problems. So I've written for you how we find the area of a semicircle. I've written for you how we find the area of a quarter circle. And then I've written for you the area of how we find a circle in general. And then, so we're going to jump in and go ahead and get started with this first problem. It says, find the area of the following semicircle. Now, I want us to remember two things. I want us to remember that this is a semicircle, so we are using the equation a equals 1/2 pi r squared, because that's how we find the area of a semicircle. And then we're also paying attention to the fact that when we find the area, we need to know the radius. And remember that the radius is halfway across the circle. So right now, they've given us all the way across the circle, or all the way across the half circle. So we need to know halfway across this semicircle. So remember that we can find the radius by 1/2 times the diameter. And so they've given us the diameter, and we're able to find 1/2 of that diameter very easily. So I'm going to multiply my radius is going to be 1/2 times 14. And if I take half of 14, I know that half of 14 is 7. So my radius is 7 centimeters. So now that I know what my radius is, I can jump in, plug 7 into my equation, and find my area. So since my area equation of a semicircle is 1/2 pi, and remember they told us to use 22 over 7 for pi, so I'm going to multiply this by 22 over 7. And my radius is squared. And since my radius is 7, I'm going to square that 7. So now I have this equation that says a equals 1/2 times 22 over 7 times 7 squared. So remember we talked a while ago about order of operations. So remember, please excuse my dear Aunt Sally, parentheses first, exponents second. So we're going to carry out the exponent in this equation first. So I'm going to rewrite my equation as area equals 1/2 multiplied by 22 over 7. And remember that when we're squaring something, we're multiplying that number by itself one time. So 7 times 7 is 49. So we are multiplying this now by 49. So now I just need to carry out that multiplication. And of course, it's easier if you have a calculator. If you don't have a calculator, remember that this is 49 over 1, and so you're going to multiply straight across. So we're going to multiply firstly 49 times 22. And so we have now area equals 1,078 over, and now we need to multiply the bottom of our fraction straight across. So 2 times 7 times 1. Well, 2 times 7 is 14. So now I have a fraction that says area equals 1,078 over 14. And what I want to try to do is see how many times does 14 go into 1,078. And it goes into it an even amount of times. So area, and meaning we don't have a remainder, the area of this semicircle is 77 centimeters squared. So remember that when we're writing area, we always square our units. And in this case, our units, they told us, were centimeters. So that means our answer is centimeters squared. So the area of our semicircle, or everything shaded in green that you see there, that space inside of our circle, is 77 centimeters squared. So that's what we're looking at today. So we're going to now look ahead at, and I'm going to erase just a little bit of this because I need just a little bit more space. So we're now going to look at, yes, ma'am. Yes, of course, I'm not going to erase anything else. Yes, I won't erase anything else. Okay, so thank you, Diana. So we're going to now look at the area of a quarter circle. And so we're going to use this equation over here that we wrote for a quarter circle, which is 1/4 or 1/4 multiplied by pi multiplied by the radius squared. So they're asking us again to use 22 over 7 as an approximation for pi, meaning instead of us using that non-terminating, non-repeating decimal, which is 3.1415 and so on, we're going to use 22 over 7, which is an approximation, or it means we're going to stop that decimal at a certain spot. And that means our answer won't be as specific as we might like it to be. So we're going to find the area of this quarter circle by using this equation. Area equals 1/4 pi times the radius. Now in this case, they already told us that our radius is 6 centimeters. So we can go ahead and plug in 6 squared into our equation. And I'm sorry, I wrote this incorrectly. So I should have written here 22 over 7. There we go. Okay, so that's what we're going to use. Now, I want to point one thing out to you guys when you see these quarter circles in the coming questions. So I want to make sure that you understand that what they're telling us in terms of the radius is that this side is 6 centimeters and this side is 6 centimeters. So if they were to ask you for the area of a quarter circle, you're understanding that both of those two sides of that quarter circle are 6 centimeters in length. So please keep that in mind. All right, let's keep looking at this problem. So now I'm going to, in my head, remember I'm doing exponents first. So I'm going to rewrite my problem as 1/4 multiplied by 22 over 7 multiplied by 6 times 6 is 36. So 6 squared is 36. And remember that that's actually 36 over 1. So I am going to multiply straight across. So, whoops, sorry guys, I dropped my pen. Okay, so 36 times 22 is 792. So I have 792 over, on the bottom of my fractions, I've got 4 times 7, which is 28, times 1 is still 28. So now I have 792 over 28. And so I'm going to see how many times does 28 go into 792. And so when I figure that out, 28 does not go into 792 an even amount of times. So I have a remainder. So we're going to write that as a decimal. So 792 divided by 28 gives me 28.285. And so I'm going to round that 8 up to 9. So I'm going to represent the area of my quarter circle as a decimal this time as 28.29. And remember, I'm carrying with me those units. So they told me that my units are centimeters. And so I remember area is always written as squared units. So I'm going to write a 2 above my centimeters. So the area of my quarter circle is 28.29 centimeters squared. And that is the final answer for that problem. So now we're going to take a look in a little bit more detail at some different shapes. So now this is going to be a combination of shapes. So today we're going to look at finding the area of different shapes. And what you're going to notice is that these shapes are different shapes combined. So you might see a rectangle with 2 half circles at the ends of the rectangle, or you might see a rectangle with a square attached to it to represent something. We're going to understand today how we can use our understanding of finding area from different shapes to find the area of the shapes that are combined. So we need to decompose or break down shapes that make up an entire region. There isn't always just one way of doing this, so please keep that in mind. There are often multiple ways of doing this. And as we go through these problems, I'm going to be sure to write out the equations for you guys. And so I highly recommend that you write those equations down for your homework assignments because there are lots of equations that we're going to use today. So it's really important for you to write down those equations. So I'm going to jump ahead now to my second example, and we're going to look at a rectangle with 2 semicircles at the end. And remember, I'm posting this online after this lesson. So if there's something that you don't get, you can always go back to the video and copy that down real fast. Okay, so we're going to take a look at example number 2. So example number 2 says Marjorie is designing a new set of placemats for her dining room table. She sketched a drawing of the placemat on graph paper. The diagram represents the area of the placemat consisting of a rectangle and 2 semicircles at either end. Each square on the grid measures 4 inches in length. So she's telling us that each of these squares here are 4 inches. So that's important information that I'm going to write down to start with. And it asks us to find the area of the entire placemat. Explain your thinking regarding the solution to this problem. All right, so as I look at this problem, I might be tempted to be a little bit scared because it looks very complicated, but it's not. All that I'm going to do as I'm looking at this problem is break it into pieces. So what I see here is I see one semicircle right here. So I'm going to outline these for us. I see a rectangle right here. And then I see another semicircle right here. So what I have is 2 semicircles and a rectangle. And so in figuring out the entire area of this placemat or this entire shape, I simply need to find the area of each of these 3 shapes. So what I'm going to do is keep in mind how I find the area of a semicircle and how I find the area of a rectangle. And so I'm going to write those out for you guys right now. And you should again copy this down. So remember that we just talked about the area of a semicircle as being area equals 1/2, because remember we're looking at half the circle, 1/2 pi r squared, because we find the area of a circle by carrying out pi r squared. So since we're looking at half a circle, we're going to divide that by 2 or multiply it by 1/2. So that's the area of a semicircle. Now we also need to find the area of a rectangle. And so we've not talked a lot in detail about finding the area of a rectangle. So I want to remind you guys that we find the area of a rectangle by length times width. Okay, so now that we know the equations to find area of a area of a rectangle and area of a semicircle, we can carry out this exercise. So I'm keeping in mind that each of these squares is 4 inches in length. And now I just need to use that information to find the area of each of these shapes. So since a rectangle is easiest for me, length times width is pretty easy, we're first going to find the area of this rectangle. So for this rectangle, I have 1, 2, 3 squares that are making up the length of my rectangle, so the bottom of my rectangle. So I'm going to multiply 4 inches, because each square is 4 inches long, by 3 to figure out the entire length of my rectangle. So 4 inches times 3 is 12 inches. And so we know that the entire length of this rectangle right here is 12 inches. Now, in addition to us knowing the inches of the length of the rectangle, we also need to know the width of the rectangle. So this length right here. So when we're looking at the width of that rectangle, I see 1, 2 squares. So now I'm going to multiply 4 inches, because each of those squares is 4 inches, by 2, and I end up with 8 inches as my width. So I'm going to find the area of my rectangle by simply multiplying 12 inches by 8 inches. And when I multiply 12 inches by 8 inches, I get an area of 96 inches squared. Remember, we always square our area. So that's important information that I'm going to add to the area of each of my semicircles. So now I understand that the area of each of these semicircles is going to be exactly the same. So I don't have to carry out the area of a semicircle equation twice. I only need to do it once, and then I can multiply that area by 2 to find the area in total of both of those semicircles together. So I find the area of a semicircle by area equals 1/2 pi r squared. And in this problem, they did not tell us to use any approximation of pi. So I'm going to use the pi button on my calculator. If you don't have a calculator and you're doing this all on in your head, or you're doing it on your iPhone calculator or your Chromebook calculator, that's perfectly okay. You can use the approximation pi equals 3.14 or pi equals 22/7. It's entirely up to you. It doesn't matter. my answer here will just be a little bit closer to the actual answer than if we were to approximate pi as 3.14 or 22/7. Now, I need the radius of my semicircle. So remember, I'm looking at the diameter of my semicircle when I'm looking at the entire side length of that semicircle. So I'm not looking for the diameter, I'm looking for the radius. So I need now just one square. So the radius of my semicircle, of each semicircle, is 4 inches. So my radius is 4 inches. All right, so area equals 1/2 pi multiplied by 4 inches squared. Okay. Now I'm going to show you guys that you can represent this in two ways, and it doesn't matter which way. There will be an easier way for this problem. Now, I now have 1/2 pi multiplied by 4 times 4 is 16. So times 16. Now I can multiply right now 16 times 1/2, or 16 divided by 2, and 16 divided by 2 is 8. So now my equation, or my area, reads 8 pi, and I can stop there if I want. But it's going to be easier for me to add the area of my semicircle to the area of my rectangle if I have an actual decimal. So now I'm actually going to multiply 8 times 3.14. I'll just use that for now. I'm actually going to use the pi button on my calculator. So 8 times pi is 25.13. And now remember, that's inches squared. So that means that the area of each of these semicircles, the inside of each of these semicircles, is 25.13 inches squared. So now, since I have two semicircles, I'm going to multiply that number by 2. And so the area of both of those semicircles combined is 50.27 inches squared. Now remember, she's asking us to find the area of the entire placemat. So now we know the area of each of these shapes inside the placemat. And so all we need to do is add those three areas together. And we actually combined the area of those semicircles into just one area. And that was 50.27 inches squared. And so now we're going to add to that the area of the rectangle, which was 96 inches squared. And so when we add those two numbers together, we get 146.27 inches squared. And that is the area of our entire shape. So that is the entire inside area of that shape, both the semicircles and the rectangle combined. So we're going to find the area of a shape, whether it be multiple shapes combined together or just one shape. In terms of multiple shapes combined together, we're going to find the area of each shape and then add those areas together. So I want you to keep that in mind. Now I want to look at this next question here. It says if Marjorie wants to make 6 placemats, so 6 placemats look like this one up here, how many square inches of fabric will she need? Assume there is no waste. So that means that I'm going to take the area that I just found, which was 146.27 inches squared, and I'm going to multiply that area by 6 because she's going to make 6 of those placemats. And so what I find out is that when I multiply that out, she needs 877.59 inches squared of fabric to make those 6 placemats. So they were simply asking us to multiply 6 by that number, 146.27 inches squared. And so we find the total amount of fabric that she needs to make 6 of those placemats. Now we're almost done with this problem. They ask us one last question, which I want to go to on the next slide. So I'm going to flip ahead, but I'll be back in just a minute. Okay, so it says Marjorie decides that she wants to sew on a contrasting band of material around the edge of the placemats. How much band material will Marjorie need? So I'm going to go back to this problem really quickly, and I want to take a look at our shape here. So I'm going to erase this stuff. Okay. Excuse me. Now, We just found the area, which was the entire inside of these shapes combined together. Now she wants to put something on the outside of these shapes, kind of add extra, maybe frilly material. Sometimes we see frillies on the end of a placemat, or some kind of band. So she wants to put it all around the outside of the placemat, just like that. So that means we need to find the perimeter of this shape. So that means that we need to find the perimeter of the rectangle and the perimeter of these semicircles. So I want to flip ahead now because I want to show you guys something. I want to write this all out. Okay, so we find the perimeter of a rectangle, or the outside of a rectangle, how big it is, by simply multiplying 2 times the length, and I'm going to write it as a cursive L so that you know the difference between a 1 and an L, plus 2 times the width, because we have 2 lengths and we have 2 widths. So that's how we find the perimeter of a rectangle. Now, we need to find the perimeter of a semicircle. So remember, the perimeter of a circle is the same as the circumference of the circle. So I'm going to write that down, circumference. Okay, so we find the circumference of a circle by 2 pi r. So we need to find the perimeter of a semicircle, or the circumference of a semicircle, meaning all the way around that semicircle. So remember, the circumference of a circle is all the way around that circle. So we came up with an equation last week to find the perimeter of a semicircle, and we wrote it out as the perimeter equals 2 times the radius plus pi times the radius. Now, as we're finding the perimeter of this shape, these shapes together, I want to point out 2 things. I want to point out firstly that 2 of our shapes, actually 3 of our shapes, are sharing sides. So I want to point out this side right here and this side right here. So really, that has to be either the side of the semicircle or the side of the rectangle. So what we're saying is either the rectangle does not have a width, technically, or the semicircle does not have a width or a diameter. So as we're looking at this problem and we're trying to find the perimeter of the entire thing, we're keeping in mind that at some point, as we're carrying out these 2 equations, we're going to take into account those 2 sides there in one way or the other. So as we're finding the perimeter of the rectangle, we're going to exclude the width for now because it's not really the width of that rectangle. So I'm going to go back one more time, and we're looking at the length of the rectangle. So we have 1, 2, 3. Remember, we found that the length of that rectangle was 12 inches. So for determining the perimeter of this rectangle, I'm going to do perimeter equals 2 times 12 inches. And that's all I'm going to do for the perimeter of this rectangle, because technically this rectangle doesn't have a width. Even though it looks like it does, those sides are being shared. So we're keeping that in mind. So 2 times 12 inches is 24 inches, and perimeter is not squared. So I'm going to leave it as 24 inches. Now, as I'm looking at the perimeter of the semicircle, so remember, if I go back, the edge of that semicircle, remember the radius was 4 inches, the entire diameter is 8 inches. So if I were to do all the way across, that's 8 inches. So I am ignoring firstly this 2 times the radius as I'm looking at finding the circumference of this semicircle. And that's because I don't need to take into account that, because I'm not really looking at the entire semicircle. I'm only really looking at part of it. So when we're looking at problems like these, we're going to ignore that 2r. So I'm going to find the perimeter of my semicircle by simply multiplying pi times my radius, which was 4. And so if I multiply pi times 4, I get 12.57 inches. And remember, we actually have 2 semicircles. So I need to multiply this 12.57 inches by 2. So I'm going to multiply that by 2. And when I multiply it by 2, I get 25.57 0.13 inches. So that is the perimeter of both of my semicircles combined. So if I'm going to find the perimeter of this entire plate,